Greetings of the day, dear students. Today in this video, we are going to discuss about the concept of active power or real power and apparent power, and also about the power factor. This topic is very important during objective exams. Also, number of bits can be answered, right, by knowing this concept. And we will discuss first apparent power or complex power, apparent power, complex power or total power, and slowly we will define what do you mean by complex power. And next we will discuss some points with respect to the power triangle and impedance triangle, and we will see how to do some problems to calculate the apparent power, real power or active power or true power, and reactive power and complex power. For the same given simple problem, we will calculate all these powers, right? And also we will draw the phasor diagram for the obtained thing, right? Yeah. Now coming to the apparent power, which is in volt ampere, it is nothing but the product of RMS values of voltage and current. Very, very important. It is the product of RMS values of voltage and current. If you observe the complex power, slight difference will be there. It is the product of RMS values of voltage, phasor, and complex conjugate of RMS current phasor. This is where the slight difference we will get. So apparent power, we will denote that with letter S. We will denote that power with letter capital S, complex power, right? And the units will be volt ampere. The units will be what? Volt ampere. You may get a doubt, sir, power no, we have to express in watt. WATT, watt. Yes, if it is active power or real power, we will express it in watt. But if it is apparent power or complex power or total power denoted with letter S, we have to express it in volt ampere. If the magnitude is high, we will write in terms of kVA also, kVA or MVA, megavolt ampere, kilovolt ampere, like that we will express. Now see here, already we have completed the sinusoidal representation. That is the first topic of AC circuits, right? If you are having voltage V of t equal to Vm cos of omega t plus theta v, this is the sinusoidal representation. And also we have completed phasor representation. In phasor representation, we will denote it with capital V equal to Vm at an angle theta v. Very, very important. So first one is the sinusoidal representation. Now capital V equal to Vm at an angle theta v, this is the phasor representation, where Vm indicates the peak value. Vm indicates what? Peak value. Similarly, if you are having current I of t equal to Im cos of omega t plus some at an angle theta I, at an angle theta I. Now what about its phasor representation? Yeah, capital I equal to Im at an angle theta I. These two are the phasor representations, right? Now let me calculate the average power. P average is given by half Vm Im cos of cosine of the angle between these two, between the voltage and current, cos of theta v minus theta I, cos of theta v minus theta I. Now this 1 by 2 can be written as Vm by root 2 into Im by root 2. The meaning will not change. Vm by root 2 into Im by root 2. Now already we have seen, if V of t equals to, for sinusoidal, Vm cos of omega t plus some theta at an angle theta v. Now what about its RMS value? we have seen this derivation. Vrms is equal to Vm by root 2. Vrms is equal to Vm by root 2. Right? Now that is what? Vm by root 2. In the place of Vm by root 2, please simply write Vrms. And in the place of Im by root 2, just simply write Irms. Clear? Now the product of these two, Vrms and Irms, I will denote it with with the letter S, which represents the apparent power. Which represents which power? Apparent power. So now please look at the definition again. It is nothing but the product of RMS value of voltage and current. Simply Vrms into Irms. Very, very important. Very, very important. S equal to product of Vrms into Irms. If sinusoidal is given, Vrms value simply you take it Vm by root 2. Irms value Im by root 2. Clear? Yeah. Now this P, real power, P equal to S times cos of theta V minus theta I. Now what about complex power? It is the product of Vrms and Irms conjugate. The only difference with respect to conjugate you will get is, instead of theta I, you will get minus theta I. Now already we know this V represents the phasor Vm at an angle theta V. I equal to Im at an angle theta I. Right? Now the complex power is defined as is a product of Vrms into Irms conjugate. Vrms equal to Vm by root 2 at an angle theta V. Irms equal to Im by root 2. As we are having conjugate, instead of theta I, this is important, minus theta I you have to take. Clear? Yeah. Now already you know the one basic. It is both are in the polar form. In polar form multiplication, R1 at an angle theta 1 into R2 at an angle theta 2. What is its answer? R1 R2 at an angle, the angle gets added, theta 1 plus theta 2. This is important basic. That is what we are doing here. Root 2 into root 2, you will get 2 Vm Im. But what about angle? You have to add both the angles. Theta V plus of minus theta I. You will get theta V minus theta I. Very, very important. Theta V minus theta I. Clear? Yeah. Now, if you express it in the rectangular form, if you express that in the rectangular form, S equal to the complex power, S equal to P plus JQ. Very, very important. S equal to P plus JQ. Where if you take its magnitude, only mod S, magnitude or mod, somewhere if you have seen like this, what about its mod? Root over P square plus Q square, and that is nothing but expressed in volt ampere. And if you observe the real part of complex power, the real part of complex power is P, which is nothing but the real power. Very, very important. It is the real part of the complex power. If you observe the imaginary part, what is the imaginary part of complex power? It is nothing but the reactive power. So reactive power is the imaginary part of which power? Complex power. Real power is the real part of which power? Complex power. P. We will denote it with letter P. Clear? But what about real part? It is simply, if it is in the form of, for example, if a rectangular form is given, okay, what about x plus iy? If some z equals to x plus iy, if you are having x equal to r cos theta. Do you remember this basic? And y equal to, simply imaginary part will be r sin theta. In this context, what is r? Nothing but the magnitude, root over x square plus y square. In this context, what is theta? Nothing but tan inverse of y by x. These basics are very, very important. If you are having something, a rectangular form, now this x represents r cos theta. The same x, the same thing can be represented in the polar form as r at an angle theta in polar representation, where now our x equal to r cos theta, y equal to r sin theta, and r is the magnitude root over r x square plus y square, and theta is the tan inverse of y by x. That is what we are doing here, simply to say. Now our real part will be, this is r cos theta, imaginary part Vrms into Irms sin theta, but the real power will be expressed in watt, and the reactive power is expressed in volt ampere reactive. Very, very important, volt ampere reactive. These are the units for reactive power. Now you should be very clear with respect to the units of the power. I repeat again, apparent power expressed in volt ampere, real power P expressed in watts, reactive power Q expressed in volt ampere reactive, volt ampere reactive, and S equals to P plus JQ, S equal to P plus JQ. Clear? Now the power factor, the angle that is existing between the, for example, if this is the voltage phasor, and if you are having a current phasor like this, and if there is some 30 degrees angle between the voltage and current, then that cos 30, the cosine of the angle between voltage and current, very simple, cos 30 is called the power factor. This is nothing but the power factor. So the power sin 30 1 by 2, cos 30 root 3 by 2 is the power factor. Cosine of the angle between which two voltage and current phasor is the power factor of the given context. Now P, if you, P is already known, Vrms into Irms cos of theta v minus theta I whole divided by S. Now this Vrms into Irms and this one will get cancelled. Just we will get only cos of theta v minus theta I. Now how do you understand this theta v minus theta I? It is nothing but the angle difference between the voltage and current. Cosine of the angle between voltage and current is nothing but our power factor. Clear? Yeah. Next. Now just like in the previous discussions we have seen the impedance triangle, we are also having the power triangle. Very, very important. These two triangles are very, very important. This is called power triangle. This is called impedance triangle. If you observe, S equal to P plus JQ. Now we are clear. S represents complex power, P real power, Q reactive power. Magnitude of S, mod S, equal to root over P square plus Q square. Angle theta equal to tan inverse of Q by P. Similarly for impedance, this is the resistance and this is the reactance X. What about mod Z, root over R square plus X square? What about theta? Tan inverse of X by R. Now let me see the units. S equal to some mod S at an angle theta. This is complex power in polar representation, right? This is apparent power, mod S. Mod S equal to Vrms into Irms. The units are volt ampere. Now active power P equal to S times cos theta. S times cos theta. Or Vrms into Irms cos theta. The units are watt. Q reactive power S times sin theta, mod S times sin theta. So Vrms into Irms sin theta. The units are volt ampere reactive. Power factor Pf equal to cos theta. Right? Now the total power that appears to be transferred between the source and load, is called the apparent power. Very, very important. Apparent power. That power appears to be transferred, but out of that much amount of power which appears to be transferred, okay, some part of the power which is actually consumed in the circuit is called the true power or active power or real power. Very, very important. Please remember these two keywords. Apparent power appears to be transferred. the power that appears to be transferred. Out of that much which appears to be transferred, what is actually consumed, that represents the true power. True power, in some textbooks they will write it as active power, or in some textbooks they will write it as real power. All these three words are correct only. Expressed in watt. Clear? Yeah. Now, at the starting stage itself we have discussed the pure inductor or pure capacitor does not consume any active power. Then which element consumes the active power? Resistor. Resistor consumes the active power. So if the inductor or capacitor is pure, they won't consume any power. Right? Now, out of the apparent power, some component of the power will be circulating, which is circulating. That circulating power is nothing but the reactive power. Very, very important. Now here in this context itself, the three powers meanings are very clearly explained. Apparent power, which appears to be transferred. Simple. Real power, which is actually consumed. Clear. Reactive power, power which is circulating, called the reactive power. Okay, yeah. Now let me do the small example. In this problem, a voltage of 311 cos omega t is applied to a resistor and inductor which are in series. Inductor reactance, inductive reactance, if you remember, XL indicates the inductive reactance. XL equal to omega L. Omega L equal to 2 pi FL. And what will be the units? Ohm. For resistor also, ohm. For impedance Z, the units are ohm. Right? Yeah. Now, you know the impedance. R and L are in series. What will be the impedance? Z. Impedance Z will be R plus J XL. In this context, R is 2 ohms plus inductive reactance is given plus J 3 ohms. This is the impedance. Very, very important thing is, dear students, please observe, the impedance is defined as the ratio of phasor voltage and current. Now if I ask current, this is where most of the students will commit the mistake. That implies current I equal to V by Z. Very good. But in the place of V, you should not write this 311 cos omega t. If you write that, the entire problem goes wrong. Why? Because this V is the phasor of the given sinusoid. That is important. If I want RMS value, if I want IRMS, then you will take the phasor of VRMS. So simple. VRMS, IRMS. Now, from the known basics, the voltage is given is 311 cos omega t. It is in the form of some Vm cos of omega t. Now what about VRMS value? Vm by root 2. Vm is already known, 311 divided by root 2. This is the voltage you have to consider. If I ask current, if I ask, that implies, yeah, here we have written current I equal to V by Z. Which V we have to write? That is very, very important. Right? Yeah. Now IRMS, current IRMS equal to V by Z. Now its meaning is, if you got no angle, its meaning is 219.9 at an angle 0. Nothing wrong. If somewhere if I see some x equal to 2, I can write it as some x equal to 2 at an angle 0. It is correct only in polar form. Right? Yeah. Now 219.9 at an angle 0 by 2 plus J3. You convert this impedance also into polar form. That is the reason why, in order to do these all calculations, exclusively you are having one topic. Before watching this video, dear students, please complete this topic. Phasor representation in polar and rectangular form. There we have discussed some problems also. When you are having complex numbers or polar numbers, how to do the multiplication, addition, division and subtraction with respect to the complex numbers. There we have discussed some examples. After watching that video, you please watch this video. Clear? Yeah. Now this is in the form of R1 at an angle theta 1 divided by R2 at an angle theta 2. What will be the answer? R1 by R2 at an angle theta 1 minus theta 2, because the division of two polar numbers. That is what we will do here. 219.9 at an angle 0 whole divided by 3.6055 at an angle 56.309. Now we will get this value. So far clear? Now we got the IRMS. VRMS we have calculated. This is very important. He will give you simply V of t equal to 311 cos omega t. If you take immediately V equal to 311, you will get entire problem goes wrong. That 311 is Vm value. Vm equal to 311. But we want VRMS value. VRMS is Vm by root 2. Very caution. Right? Yeah. Now you know the RMS. You know VRMS, you know IRMS. What about mod S? VRMS into IRMS. 13.411 kVA. We have already defined real power. Once you know the S, immediately we can calculate all other remaining powers. We can calculate all other remaining powers. P equal to mod S cos theta. Next doubt arises. In the place of theta, what you should take? The angle between the voltage and current. What is the angle we got here? 56.309. That is important. Clear? It is something like this. V value is how much? 219 at an angle 0. That is something like this you got. This is V. That is 219.9 at an angle 0 degrees. What about I? 3.66. This is I. If you draw in the form of a diagram, this is I. But this is at what angle? Angle is positive or negative? Positive. Right? So that will be the angle between the voltage and current. Now mod S into cos theta you take. Cosine of the angle. The units are kilowatt. What about reactive power? Mod S times sin theta, sine of the angle. Very, very important. Don't forget the units. kVAR. We are expressing it in kilovolt ampere reactive. Now what is complex power? S. P plus JQ. P is 7.439 and Q is 11.159. What are the units for complex power? kVA. What about power factor? Cos of the angle between voltage and current. 0.5547 is the power factor. Or another definition also we have seen. Capital P divided by capital S. P divided by S. This is the power factor. Right? Now, if you observe the phasor diagram, the V is 311 at an angle 0. Current is 86.257 at an angle minus 56.309. It is rotated in which direction? This direction, clockwise, minus 56.309. This is the phasor diagram of the voltage and current. This is the power triangle PQ. S is square root of P square plus Q square. This is the power triangle. Impedance 2 ohms R. Reactance J3 and mod Z. This is the impedance triangle. All these concepts are completed. Clear? So in the next topic, in the next video, we will discuss about the power factor. Out of all these things, dear students, very, very important. Apparent power appears to be transferred, capital S. Units are volt ampere, right? Real power actually, which is actually consumed in the circuit, real power. Other names are active power or true power, expressed in watt. The power which seems to be circulating in the circuit is the reactive power, right? Next, Vi cos phi, simply to say S equal to Vi, P equals to, understood, Vi cos theta, Q equal to Vi sin theta. Understood, these values are RMS values, VRMS, IRMS. Units are volt ampere, units are watt, units are volt ampere reactive. This is mod S. If you want S equal to P plus JQ. Enough. If you know these four, then this entire topic is completed. Okay, thank you.